information on limits, and here's a quick review of limits. It's everything I know about limits in less than 10 minutes, I promise. We've got 3 limit questions here to begin with. Before we even tackle one of these questions, is you have to know that limits are y values near a certain x. The approach for ones that are of this nature right here is, first of all, see if you can just plug in the number. For an example like this, it's going to easily be done because you can take the x equals 2 and just replace it into x without any problems. You end up getting that the y value is 3. What this statement means here is that near to the y value is 3, or very near 3. When x actually equals 2, in this particular case, the y value actually equals 3. There's nothing odd happening at x equals 2. It's just another point on the graph. For one like this, here there's something very unusual happening at x equals 4. When you plug a 4 into this, you get that there's a 0 on the bottom. And you can't have that. There's no such thing as division by 0. So a way around that for question number 2, since you just can't plug it in, like example 1, is you factor out where you can. So you can take out a greatest common factor of 8 on the top, and on the bottom, break it up as x plus 4 and x minus 4. The x minus 4 factors will cancel, leaving you with 8 over x plus 4. Now you can plug the 4 into the equation, and it would give you 8 over 8, which is 1. So what this statement would mean is that near x equals 4, the y value is near 1. At x equals 4, there'd be an undefined situation. So you're not going to find the height when x equals 4, but when x is close to 4, it will be 1. For question number 3, we run into a bigger problem. You can't plug 1 in. So it's not just simply like question number 1. You also can't factor. The only other option is to take a look at what's happening with the graph near x equals 1. So since we can't plug in and we can't factor, what you want to do is take a look at the graph and see what's happening near x equals 1. Well, graphing it by hand, you could plug in a 0 for x, which gives you 4 over negative 1, which is negative 4. So that means the graph's like this. And from what I know about the way these curves move, the graph will bend in that direction. It'll also curve in this direction like so. Now you can get that information off your graphing calculator, or you can graph it by hand. Sure, the calculator is a lot better. So what's happening at x equals 1 is that's called a vertical asymptote at x equals 1. And when you see a vertical asymptote like that, automatically you can say that the overall limit does not exist. So the limit as x approaches 1 does not exist. And I'm going to talk more about why it doesn't exist in just a second. Does not exist because as you're coming in from the right-hand side, as you get closer to 1 from the right-hand side, the y value is heading towards infinity. As you're coming closer to 1 from the left-hand side, you're heading towards negative infinity. And anytime you see infinity involved in a limit question, automatically the limit does not exist. So another way to write all that is to talk about left-hand and right-hand limits. So the overall limit does not exist. But there still is a left-hand limit that exists and a right-hand limit. The limit as x approaches 1 from the left. That's what that negative means. That means, what is the y value? Or what is the height of the graph when we are slightly to the left of 1. If I'm standing slightly to the left of 1, my x value is like 0.99999. The y value would have to be living way down here because of the way the graph moves downward. So if I'm very slightly, just a hair to the left of 1, my y value is going to be equaling negative infinity. Alright, I said I could squeeze it all in less than 10 minutes, so let me just change this slightly too. If we're talking about a right-hand limit, it'll say 1 with a positive sign afterwards. It has the same exact meaning, except it means we're standing slightly to the right, in this case, of 1. So if we take a look at standing slightly to the right of 1, it means my x is over here someplace. What's the height of the graph when I'm just a hair to the right? Well, the graph's living way up here when I'm close to the 1, but I'm slightly to the right of it. So that the limit, the right-hand limit, would actually be positive infinity. All right, so for openers. That's a quick walk through of some limits. Let me show you a couple pictures on the board, and then get into some other descriptions of limits.